everyone. Welcome to today's webinar on avian influenza. Thrilled to have you joining us today. I see many in the chat. Go ahead and keep introducing yourselves if you'd like to do that in the chat. I'm Kristan Uhlenbrock. I work here at the Institute for Science and Policy at the Denver Museum of Nature and Science, and I am thrilled to be bringing you this webinar today in partnership with the Colorado School of Public Health, who helped us think through this webinar and our guests today. So a huge thanks to them. Avian influenza is commonly known as bird flu, which is maybe how some of you have heard about it. It is a significant emerging infectious disease threat here in the US. And while primarily it is a disease of affecting birds, there is a strain called H5N1 and a new subtype of that has emerged in North America that is being transferred into mammals. Both dairy cows we're seeing, as well as some pets, as well as a number of cases that have shown up in humans. Today's discussion is going to talk a little bit about the current state of avian influenza, both in the US as well as in Colorado. We're going to look at the implications of this on human health and public health, as well as the economy and our supply chain disruptions that it is creating. We have a great panel today bringing you all of that different types of expertise. And so I'm really thrilled to have them walk us through what we currently know, what do we don't know, what we're anticipating, talk about some of the risks, as well as behaviors that we should be doing ourselves to be prepared. So I'm super honored to have them here today. I'm going to briefly introduce each of them, and then we'll have some presentations, and then we'll go into discussion. So we have Dr. Amesh Adalja, thank you. Apologies for mispronouncing that there. He's a senior scholar at the Johns Hopkins Center for Health Security. He's also a practicing infectious disease, critical care, and emergency medicine physician. Thank you for being here today, Doctor.
Thanks for having me.
We also have Dr. Jack Buffington, who is the Director of Supply Chain Program, as well as an Associate Professor at the Daniels College of Business at the University of Denver, so here in our own backyard of Colorado. Dr. Buffington, thank you for being here today.
Great to be here. Thanks.
And a friend of ours who we've had many, many times over the years here with the Institute, bringing you some really timely, relevant information expertise, is Dr. Rachel Herlihy. She is our state epidemiologist here for Colorado, serving at the Colorado Department of Public Health and the Environment. She is also a preventative care physician. Thanks for being here, Dr. Herlihy.
Great to be here. Thank you.
Great. One housekeeping item as well. You all are welcome to ask questions in the chat. I encourage questions throughout today. We'll incorporate those into our conversation in this latter part of today's presentation. And my disclaimer, I send you my extreme apologies if we do not get to all your questions, but we'll do our best to incorporate as many as we can into the conversation. And with that, let me pass this over to Amesh, who will give us a state of sort of the national scope of the avian influenza. And we have some slides we're getting ready to show here right now. So thank you.
All right. Well, thank you for the invitation to speak, and thanks for signing up for the webinar. So my task is to very quickly try and get people kind of centered on what the issues are with avian influenza. It might be the first time people have heard about them. You might only have heard about it in relation to egg prices, but I'm going to try and contextualize avian influenza in the whole scheme of influenza so that you kind of have some understanding of what you're hearing later on in this webinar and when you're interpreting news reports and when you're trying to think about your own risk assessments. So that's a picture in my local state fair a couple of years ago where they stopped exhibiting poultry because of avian influenza. So although we're hearing about this now in 2025, that picture was probably taken around 2018 or so. So this is not a new thing, but there are some new elements to it. So gonna see if I can, next slide, please. So I want to kind of first situate you with thinking about influenza, because avian influenza is part of the whole family of influenza viruses. And humans have had multiple pandemics, and we've all experienced a COVID-19 pandemic, but we've had multiple influenza pandemics. And most people know about the 1918 flu. That was an avian virus that killed about maybe up to 100 million people in the world and around 700,000 in the United States. And it was very disruptive, happening at the end of World War I, when people had very little understanding of medicine. They didn't even know that influenza was caused by a virus at that time. And that was probably the worst pandemic we've had in the modern era. And it is even, it's much worse than COVID-19. 1918 was still a much more drastic level of death and disability from an infectious disease than even COVID-19. And then in 1957 and 1968, we had smaller pandemics. And I'm going to talk about what those are a little bit later in my slides, but those were not solely avian viruses. They were kind of reassortants, and I'm going to talk about how flu can do that. In 1977, we had what they call as a mini pandemic. There was a vaccine trial that went wrong, and a virus started spreading and led to an increase in influenza in 1977. And then in 2009, our most recent pandemic of flu was related to H1N1, and I'll talk a little bit about that in a second, but it led to about 13,000 deaths. So we've had multiple influenza pandemics. So the thing is, when you think about what viruses can cause pandemics, influenza viruses are number one, number two, number three on the list. Obviously, there are others like coronaviruses, which we've all been through, but flu is the biggest pandemic threat. So a little bit of science here. I know that people probably, I don't want people's eyes to glaze over, but I think this is really important to understand influenza viruses. So when you think about the genetics of influenza, the thing to keep in mind is it's almost like a deck of cards. It's not just one card that has its genetic material. There are 8 different segments encoding 10 different genes. And what that means is that those genes can shuffle when somebody might be infected with more than one strain of flu. So you've got 2 different strains of flu that you're infected with, and those cards shuffle and something new comes out. That's why influenza always is able to cause pandemics, because something new can come out. There are 4 types of influenza. The one I'm going to really be focusing on here is influenza A. That is the type that causes pandemics. And that virus was first isolated in 1933. It's really important to think about influenza as a zoonotic infection. Everybody thinks about it as something that every human gets. And if you read the works of Hippocrates, it's in there. But it naturally circulates in waterfowl. And they have multiple different versions all the time going on. And those waterfowl can then spill that infection into other organisms, including humans, including cows, including poultry. And then we have outbreaks, but it naturally lives in waterfowl. And we talk about flus based on these H's and N's. Those are proteins, and there's different types. There's 18 different types of H's and 11 different types of N, and all kinds of combinations can occur. And as I said, all of these are circulating all the time in waterfowl. So there's this opportunity for new things to come out. And then this last concept I'm going to talk about here on this slide is antigenic shift versus antigenic drift. This might sound really, really science heavy, but it's really important to understand. So every year we go through, next slide. Every year, on the right side of the slide, we go through what's called antigenic drift. The viruses mutate a little bit. The vaccine doesn't work as well. And that's kind of what we're used to. But an antigenic shift is exactly what I was talking about earlier. Those gene segments, remember, like that deck of cards that each flu virus has, they can reshuffle and intermix, and something new comes out. And that was what was responsible for the 1957 and 1968 pandemics. So that's why we worry so much about, you've got this bird flu virus that's circulating and maybe not doing much in humans at this time. But what if that human is infected with the seasonal flu virus and it shuffles? Or what if it infects a pig and the pig reshuffles a flu virus from pigs, and you get something new? Again, that's what happened in 1957 and 1968. So that's why, even though we've not seen that many humans infected with H5N1 in the United States, we worry because of that possibility of antigenic shift. Next slide. And this is a slide from the New England Journal of Medicine, kind of illustrating that process. So in 1918, the Spanish flu, or H1N1, which was an H1N virus, it was a solely bird virus. It came directly from birds to humans and led to a massive pandemic. But then in 1957 and 1968, you saw avian viruses reshuffle with something that was already circulating in humans, causing a new pandemic. So that's what we really worry about, is maybe it's not going to be H5N1 that can cause a pandemic, but could it reshuffle its genes with another flu virus that's out there that's better able to infect humans, better able to spread among humans? That's what we worry about. That's why flu is kind of at the top level of pandemic threats, because of this phenomenon, which isn't something that you see with many other viruses. So that's why when you think about pandemic preparedness, flu focus is heavy. The focus on flu is very, very heavy. Next slide. And this is just another slide illustrating what I talked about, that shorebirds and waterfowl, that's where flu normally circulates, and then it can spill into domestic birds, into swines, and into swine species, and into humans as well. So it's important to remember that there's this natural avian influenza cycle. So you can't really interfere with the natural avian influenza cycle. That's going to happen all the time. What we have to do is deal with the domestic birds, swine, humans, other mammals that the virus can be infected with. Next slide. And one of the things, this is again another heavy science slide. So why can't bird viruses infect humans? It has to do with the receptors. We don't have the same receptors as birds. So the bird receptors are really what the bird viruses are going to be binding to. So these alpha 2,3 sialic acid receptors. I don't want to get too heavy on the science, but to put it simply, the viruses that circulate in birds are adapted to that receptor. We primarily have alpha 2,6 sialic acid receptors. So that means bird flu viruses can't really infect us that well in the upper respiratory tract. We do have those receptors in the lower respiratory tract, but not in the upper respiratory tract where the flu virus actually lands when you get infected. So when you hear them talk about, is this virus mutating? Did they find any dangerous mutations? One of the things they're looking for is the virus changing its preference for receptors to be able to bind the human type now and move away from the bird type? So that's kind of what keeps this at bay, is this difference in receptors. That's why avian flu viruses have a hard time infecting humans, because they don't have an easy way in. But they can mutate, they can acquire genes from other flu viruses that allow them to do that. And that's what we worry the most about, is that change happening. Next slide. This is just a schematic to think about how can a flu virus become a pandemic virus. And I just wanted to walk you through it very quickly. So first of all, an avian strain has to be widespread in wild or domestic birds and expose humans to infection. It has to be something that humans come into contact. Humans have to get it, and the virus has to replicate or multiply enough in that person so that they're infectious, and then it can spread to somebody else. And then it has to spread widely. So we're sort of in this 3-4 strain that we're getting with H5N1. One or more humans have definitely acquired it, but it's not really spreading amongst humans. So we're not quite to the 3-4 stage, but that's what people are looking for. And there are other flu viruses that bird flu viruses that we worry about that have kind of traversed 3 and made it into 4. But right now with this one, we're kind of back up here at 2, which is, I think, reassuring to most people, but we don't know when or if it could develop these characteristics. Next slide. And this is just a slide, no reason to memorize it. I just want to give you this there to show you that there's multiple different avian flu viruses that have been infecting humans for quite a long time, including back in 1959, and clearly before that. Obviously, 1918 was a bird flu virus, but there's a lot of bird flu viruses that are out there. So we talk a lot about H5N1, which first appeared in 1997, infecting humans in Hong Kong. But there are many different versions of flu viruses that are always out there infecting humans. So that's another thing to keep in mind. That if it's not H5N1, it may be other ones. One of the ones that I worry the most about is H7N9, which you can see on the right slide. That's caused multiple outbreaks in China, some of which have been quite severe. Next slide. So in 2022, we started to see H5N1 outbreaks in poultry. And what was different about this H5N1, these outbreaks that were happening in poultry, was that we're also seeing these kind of side infections of mammals, especially sea mammals, bears, skunks, foxes. And that's important because remember, I know we're kind of in an anti-science era, but humans are mammals too. So if something can infect a mammal, it's getting closer to being infecting, humans, which are mammals. So that's why we really worry about mammalian type of infection. So that's why this started to change the stakes with H5N1, because it was infecting so many mammals, causing lots of sea mammal kill-offs in many parts of the world. Next slide. And then things really changed when it infected cows. So cows aren't usually infected with influenza viruses, except for influenza D. It's not something that cows usually get. It was kind of on a fluke that someone tested for it, and they found it because it was causing not flu-like symptoms in cows, but diminished milk productions. The cows were not very sick, and the herds started to get infected after new importations of cows from other herds. And people think this was likely being spread by the milking equipment. I'll defer to some of my other panelists to talk about the stuff that goes on farms, but maybe the milking equipment, maybe the personnel. And there was major testing issues that many farms did not want their cows to be tested. This is a major economic loss when these cows can't produce milk. And it was very difficult, I think, to get a handle on it. I think your state, Colorado, deserves a lot of credit. You guys got hit hard early on and were pretty aggressive compared to other states in terms of getting a handle on this. And what we then saw were multiple human cases, mostly mild in poultry workers and as well as in cattle workers. It's particularly causing eye infections where people were basically getting squirted in the eye with infected milk. And there's issues with pasteurization, which is RFK Jr.'s favorite type of the opposite of the favorite type of milk that RFK Jr. likes. He likes unpasteurized milk, but there's issues there that came up, and we've seen mostly mild cases with some exceptions. There has been one fatal case in the United States in Louisiana. There was a Canadian teen who got a very severe case. And in Colorado, you had a case imported from a person hospitalized in Colorado from Wyoming that had a severe case, which other people probably know a little bit more about. So we have had some severe cases and hospitalizations, but so far they've not been the common thing. And that might be because younger people are getting infected. There may be some cross immunity. It might be the way people are getting infected, but that's kind of where we sit. And I think that this is much more widespread because we don't really have full situational awareness because we've been very constrained in testing cows and in testing humans. Next slide. So these cow infections probably began in December. We thought it was a single introduction of a specific type of H5N1, but now we've noticed that there's a second introduction as well. So this probably has happened more commonly than we thought from wild birds to cattle. We haven't seen any major mammalian adaptations. Yes, it's infecting mammals, but we haven't seen the worrisome, scary mutations in enough degree to be able to kind of change our risk assessment. Cats are becoming something that are in the news. Cats are getting infected and from raw pet food, and that may be an avenue for humans to get infected. It may also be a major issue for veterinarians to deal with. And we've also seen a pig get infected, but not really pass it on or do anything because it was not part of a commercial flock. Pigs are very important because pigs can be infected with multiple different types of flu viruses, and they're considered sort of the mixing vessel, as I talked about with 1957 and 1968. Next slide. And that's my little introduction. Hopefully I didn't go too far over.
Not at all. Thank you so much, Amesh. And Rachel, thank you for bringing it down to the Colorado experience.
Great. Thank you so much again. Really great to be back here with all of you. So we're going to switch gears. I'm going to briefly walk you through a couple of slides and share specifically Colorado's experience with H5N1 avian influenza. So share our story to date. Next slide, please. And really all good outbreak stories start with a timeline. So that's where we're going to start here. As you just heard, H5N1, specifically a clade or strain that we call 2.3.4.4b, that's a lot, we don't need to remember that, was first detected in the US in early 2022. And Colorado was really pretty early on the scene with our first detections in wild birds, you can see on this slide, and then commercial poultry. We also had, if you look at the far right upper corner of this slide, a confusing human detection in April of 2022 in a person who was engaged in poultry depopulation or culling activities in response to an outbreak in poultry. That person, their only symptoms reported were fatigue. That person tested positive, but to this day, we're really uncertain if that person actually had infection. And then, like states around the country, for the last 2 years, we were actively monitoring individuals with exposure to infected poultry and wild birds, occasional mammal exposures, as you just heard, but really a focus on poultry and wild birds. And then, as you heard, there was this change where we saw widespread detection of H5N1 in dairy cattle, including here in Colorado, again, pretty early on. April of 2024. I think I'd like to give credit to our agricultural department here for detection, good partnerships that led to these identifications in Colorado and our response, of course. And then you can see that shortly after that, we saw another round of outbreaks in our poultry industry. And really, if you go to the next, click forward, it's really these two different outbreaks, the dairy cattle and the poultry, that I'm going to focus on for the next couple of slides. All right, so bottom line up front, Since 2024 in Colorado, we have had 64 confirmed positive herds, and that's more than 75% of our herds in the state. For poultry, we've had 9 backyard poultry flocks that have tested positive and 4 large commercial flocks that have tested positive for a total of 3.4 million birds. So very large numbers we're talking about. As you've heard, we've had some domestic cats with some varied exposures, some exposed directly on dairy farms, and then some other mixed exposures, including exposures to wild birds. These are cats that are outdoor cats and hunting, as well as raw pet food. We've had a total of 10 human cases in Colorado. All of those have been mild. This 10 does not include the Wyoming resident that was hospitalized in Colorado. So that is a different case and not counted in Colorado's counts. Next slide, please. So starting with our dairy experience, I first want to emphasize the importance and emphasis we've taken here in Colorado on what we call a One Health approach in responding to H5N1. And if you're not familiar with that term, it's basically a strategy of recognizing that human health, animal health, and environmental health are all really closely tied together and all need to be considered together in our response work. And that has really been a focus of our response in the state. We've worked very closely with our animal health colleagues at the Colorado Department of Agriculture, and some examples would include things like joint briefings to the governor's office, joint town halls with the public and media, speaking with a single voice to the media so that we're on the same team and it's clear that we are working together. And really importantly, our agricultural partners, when we've gone into the field, have introduced us as trusted partners. And that's been really important because in public health, we really don't work closely with farms very often. And so those relationships and that partnership with our agricultural partners has been really important. So the types of things that we've been doing on these farms are interviews when we worry that cases may be occurring, at site visits, coordinating with our agricultural partners, including federal partners, USDA. We observe workspaces to see where risk of exposure for people might be occurring on dairy farms, talking to workers about their potential risk on these farms and exposure to the virus in milk, as you heard about. Strategies for risk reduction, including the use of PPE or personal protective equipment, providing PPE to farms and the workers on those farms, including masks, goggles, face shields, gloves. And then when we had workers that have developed symptoms, testing those workers and providing them with antiviral treatment with Tamiflu, also known as oseltamivir. And then monitoring any workers that have exposure for 10 days to see if they develop any symptoms after their exposure. Next slide. So ultimately, our outcomes have included, oh, sorry, there's a duplicate number here. It should be 64 affected farms, about 1,500 farms that receive PPE. Sorry, the numbers are a little odd here. 19 monitored workers, and then 1 human case. So those are the total outcomes that we've experienced on our dairy farms. Next slide. So switching gears to poultry, as a reminder, here in Colorado, we've had 9 human cases of H5N1 associated with exposure to 2 different poultry farms. So again, 10 human cases, 1 associated with the dairy farm, and then 9 associated with poultry farms. And this is an article in CDC's MMWR report that you can find online that nicely summarizes our experience with these poultry outbreaks. Next slide. In contrast to our dairy farm response and exposures, which took place really over multiple months, our poultry response was really condensed into not much more than 2 weeks. And because of the large number of poultry workers that are on these farms after infections are identified, there's really a large number of people that are involved in this depopulation or culling work that has to happen once a farm is infected, that there's a lot of workers being exposed. And so that resulted in a very resource intensive response from public health on these farms and also from our agricultural partners. So what happened is that we received a report from first one poultry farm and then a second poultry farm about individuals working on the farm that were having symptoms, primarily respiratory symptoms, but also really challenging at the time of this response this past summer was the fact that it was over 100 degrees in Northeast Colorado, where these farms are located. And that extreme heat was probably also contributing to some of the symptoms that workers were experiencing. So, one of our first goals in responding was trying to identify whether the illness that we were seeing on these farms that had known H5N1 avian influenza infections was related to the virus or if it was something else. So we were collecting information from the workers on their exposures, their symptoms. We collected clinical samples from infected workers. We treated symptomatic workers, gave them oseltamivir or Tamiflu medication to treat their symptoms. And then we also did quite a bit of work to try and prevent future illness from occurring in workers. So raising awareness about the potential risks of exposure on these poultry farms, providing education on prevention strategies, and supporting the proper use of PPE. If you remember me telling you it was over 100 degrees on these farms, that was really significantly contributing to the risk on these farms, and that wearing PPE while doing this work is challenging to begin with, but it's particularly challenging when it's 100 degrees outside. I mean, think about wearing, a Tyvek suit, an N95 respirator, gloves, all of this stuff when it's 100 degrees, it's really uncomfortable. And so that was really one of the challenges in these farms was the really difficult situation under which these workers were responding. And then one of the other things that we ended up doing on these farms was providing preventive treatment. So we provided Tamiflu medication to people that were exposed before they developed symptoms to prevent additional cases. Next slide, please. So in summary, on 2 different affected farms in Colorado this summer, we had a total of 65 symptomatic workers on one farm, 44 on the other. On that first farm, Farm A, we had 6 that tested positive for H5N1 influenza. On the second farm, that was 3. And then you'll see here that we also had individuals testing positive for COVID-19. So specifically on Facility B, we actually had a coexisting outbreak of COVID-19 that also made the situation a little bit confusing, plus the high temperatures. So again, our work as epidemiologists was to try and sort out what the cause of illness on those farms was. Next slide. So some of our key takeaways. So we used a One Health approach to successfully engage dairy and poultry producers in our response to H5N1 in Colorado. Dairy and poultry workers really continue to be at increased risk of H5N1 infection in Colorado and the US. And a recent risk assessment by CDC does talk about their risk as being moderate or high compared to very low risk for the general population. The focus of our response recently, so this is really in 2024 and since then, has really been a little bit more focused on dairy farms as a new emerging issue. But this experience for us on these poultry farms really pointed out that there's really significant risk on poultry farms, again, with 9 cases occurring in Colorado. We know that PPE is a really important risk reduction strategy, but there are lots of challenges, keeping in mind the high temperatures that I mentioned. And there's lots of work that I think we need to do in public health and clinical medicine to really try and improve PPE and better protect workers. Thank you.
Thank you, Rachel. And some final remarks to wrap up our sort of introductory presentations from Jack, talking more about the supply chain side. So Jack, take it from here.
Thanks, Kristan. I work in a business school, so I often introduce myself recently as the guy talking about the other AI. It's an interesting storyline there. One thing I wanted to start with is that the root cause of what's happening in the economy and with egg prices. By the way, I'm going to tell you a story. I don't have any slides, so hopefully this works. The root cause of what's happening isn't the bird flu. Just like what's happened in the past with COVID wasn't the root cause, just what happened with product recalls, hurricanes, things like that would happen with the supply chain. The root cause of what is happening right now with egg prices has to do with the scale, capacity, and the focus on price relative to our supply chain. And to emphasize the story, I'm going to give you a comparison between the United States and Canada. I'm going to talk about eggs. I'm not going to talk about poultry. There's a difference in how bird flu is impacting one versus the other. And if you want to understand why that's the case, we could talk about it later. But right now, I'm just going to focus on eggs. So in a stable supply chain in the United States produces 12 to 15 times the number of eggs that is produced in Canada, and our prices are about half the price. Now, to link to another current event story of tariffs, the other thing that I talk about a lot is Canada does have tariffs and quota system in place with the United States for the simple reason that given our scale and our price model, if it was a free market, we would flood the market and we would impact their farmers. So that does exist. The Canadian model is much more of a controlled model where the number of hens in a facility is averaging about 20,000. 95% of all eggs in the United States are produced in production facilities over 75,000 hens and sometimes up to 150. So you can see the number of hens in one facility in the United States is significantly larger than in Canada. They have probably about 1,200 production facilities. We may have like 150. So you see a much different supply chain model that's in place. And some irony in the story is, even though there's tariffs and production quotas that Canada's having right now, Americans are going across the border and trying to sneak eggs in from Canada because the price of eggs in Canada right now are cheaper than they are in the United States. So this really is a story of efficiency and production capacity versus resiliency. Rachel talked a lot about biosecurity measures. I think that's really important. It was really good how she talked about the challenges associated with that. So the problem is in these facilities getting managed to a certain extent. There are the challenges that Rachel mentioned, including the nature of the worker. There's a lot of workers or migratory workers, which are more difficult to manage when any sort of problem happens. So that is very much of a challenge. But what's important to understand is that what's happening with eggs is not unique to what's happening within other supply chains. I think we all kind of know what happened with COVID. But since then, we've had other big examples of supply and price shocks due to the way our supply chain's built. In 2022, there's a baby formula shortage due to a product recall. Again, it has to do with the focus on scale and price in our supply chains. Just past year, the beginning of the year, there was an insulin supply and price shock. Had to do with production capacity. It also had to do with the fact that GLP-1 drugs, Ozempic drugs, are becoming popular. So one of the big suppliers is shifting supply. And then just at the end of last year, there was a hurricane that hit a production facility in North Carolina responsible for 60% of our IV fluids and salines. And so that disrupted that, which, by the way, that facility was put in place because in 2017, a hurricane hit the facility in Puerto Rico, and we thought we needed more resiliency. So you can see the challenges that we see with our supply chain because we want to focus on scale and price comes often at the cost of resiliency. So just to finish up, what do we do about this? Well, we have two options. One is something that was been called for a lot during COVID is when we talk about resiliency, a lot of times what we're talking about is descaling. So in Canada, you have these smaller farms. China is the number one egg producer in the world. The United States is number two. China has much more resiliency in their supply chain where it's more decentralized, which some people could say is the solution. But the problem with that is at a steady state, that would increase the cost of eggs. And I think you all probably know that consumers aren't going to go for that, right? This topic that we're talking about, most people are concerned about the price of eggs. So that's probably, I would consider a non-starter option as a way of mitigating this problem. Bless you. The other, I'm a professor, so I watch people want to talk. So the other option, it kind of ties what Rachel was talking about with biosecurity, but quite frankly, given the scale of our facilities today, we need more stricter measures. And so I consider there to be a difference between what we're doing in biosecurity and what supply chain manufacturing needs with industrial engineering. And these facilities are not as strong as they need to be given the scale, and having the right process controls in place in order to manage the scale. So I think that's the optimization of resiliency and costs. And if this was my responsibility, that's what I would focus on, because we can't have this false narrative of saying, well, let's just do what these other countries are doing because at a steady state, egg prices will go up. But we do need to address this problem because, as my colleagues would tell you, what's happening in these huge factories is the biggest risk for this virus, because you have all these animals that are in close quarters, which leads to outbreaks and also leads to potential mutations. So it's a big challenge, but it's a challenge that we face in other areas of supply chain. And after COVID, if these things keep happening, we need to understand the root cause differently than a hurricane, a pandemic, or a product recall.
Great. Thank you, Jack. Appreciate that. We'll head into some questions in here. So if you have some in the chat, please drop them in. I'll work them in. I wanted to start with something that each of you have kind of touched on a little bit, but maybe Rachel, you can kick it off and others can chime in, which is around the surveillance of this. Like you mentioned, the reporting that kind of comes into you all and you all get deployed. Break it down for us. How does surveillance work, both here in Colorado and nationally, to really keep our eyes on monitoring the avian flu?
Sure. So I think there's a couple of things to touch on, maybe three. I think there's surveillance that's happening on the agricultural side, and Colorado is a fantastic model for this. We were the first state in the country that implemented what we call a bulk milk testing program. This means all of Colorado's licensed dairies submit a milk sample on a weekly basis. It's moved to twice weekly now that Colorado's listed as an unaffected state. So weekly testing of milk on farms. And that's, of course, important for agricultural response, but on the human health side, our side, it's also really important for public health and protecting workers. And in that we know when there's cattle that are ill, dairy cattle that are ill, and milk that's contaminated, that's potential human exposure that we need to be worried about. So that's really, I think, the front line for dairy surveillance. On the poultry side, there is routine testing of poultry for avian influenza. When birds die on poultry farms, there is routine testing that's done to look at what a cause of that illness may have been. So that work is ongoing as well. On the human health side, I think there's two things I would touch on. The first would be the work that we're doing around people that we know have exposures. And so that's some of the work that I was describing to you, the monitoring that I briefly touched on. So when we know people have exposures, we work with the farms where they are working to monitor them until we believe they are no longer having an exposure. And so monitoring basically means we're touching base with them. We're asking them to contact us if they develop symptoms. If they develop symptoms, we want to get them tested and treated. So that's really that frontline surveillance and monitoring work that we're doing. Much less direct is the routine influenza surveillance work that we do every single year. This year has been a little bit different in that we've enhanced some of that work. The two main ways that we've enhanced that work is that we are doing more influenza subtyping on specimens coming out of our hospitals in Colorado. So this means identifying the specific type of influenza that a patient might have. If you get tested for influenza and test positive, you'll get treated with, and you're hospitalized, you'll get treated with antiviral medications. It really doesn't matter which type of influenza you have if it's a regular type of seasonal flu. But we're going a step further, and our state lab and clinical labs are doing more of this subtyping to see if there's any H5N1 influenza that we might be missing. The other thing that we're doing in Colorado is wastewater surveillance. So we are every week, collecting samples from 20 different wastewater sites in the state and looking for specific types of influenza. We're looking specifically for H1 influenza, seasonal influenza, H3 influenza, another seasonal type, and then H5 influenza. So a number of things are ongoing on the animal health side and on the human health side.
I just want to add one little thing to that. I think that Colorado is exemplary. And when you compare it to other states, for example, Missouri had a human case where they don't know where this person got it, but they're saying, we've never had a herd positive, we've never had bird flu here, but they're not actually doing any of the work that you see in Colorado. They're not proactively going out there looking for it. And I think the assumption should be in all states that bird flu is probably going to be here. It may be in our cattle herds. It might be in our poultry herds. We're going to find it. We're going to uncover. We're going to look for the needle in the haystack. But many states, it's kind of see no evil, hear no evil, and that puts us really behind the eight ball. And I think Missouri is a state that I draw out. I think there's other Midwestern states that have done that. And I think what you want is the Colorado model where they're proactive, looking for it, assuming it's going to be there, rather than not wanting it to be there and then not looking for it and then saying, oh, it's not there. But they didn't actually look that hard. Colorado looks hard, so that you have a lot of fidelity in what they're doing versus other states where they're not really looking hard unless they're pushed.
What about, I've got some obvious questions I'm going to come to here, but you all have mentioned, biosecurity measures a little bit here a couple times, right? And that's the idea of preventing that virus from spreading. For those of you who aren't familiar with that term, please correct me if I misidentified that definition of what biosecurity at a baseline level means. So what are some additional steps around biosecurity that we could be taking, or are we considering, whether that's from vaccines to all sort of measures? I'd be curious what's currently in place that we haven't talked about and we should be considering. Jack, you're on mute if you want to kick that off. Jack, you're on mute.
So in manufacturing, we consider every problem to be able to be mitigated. And so I'll be honest with you, because our poultry farms are often rural and they're, kind of away from a lot of things. They don't have the same process controls that we have in other industries in manufacturing. I probably don't have time to go into all of it. I'd be happy to share it with anyone offline. But there's significant opportunities, what I classify as industrial engineering. Biosecurity is what you do when something goes wrong. Industrial engineering, better manufacturing processes, is what you do proactively to avoid a problem from the start. So don't have a lot of time to go into that, but I think the problem I have with some of what we're doing in biosecurity is it's reactive instead of proactive. That'll only do so much.
Anything else on the vaccines?
One thing I'll say on the vaccine, though, if you're talking about vaccinating the birds, there is a lot of impact on economics and trade if we do that. Like some of our partners will not purchase, birds or eggs or subset, and it's also a logistics challenge.
And there are some countries, I see in the chat, someone's asking other countries, places like France and Netherlands, they are using vaccines more strategically than we have. And again, as Jack says, it's a lot of it is kind of mercantilist trade issues because some countries, including the US, ban poultry that are vaccinated, even if you're vaccinating unrelated poultry to what you're importing, there are bans in place that need to be worked out as we think about vaccinating poultry. But I think it is something where France has done it, and I think they vaccinated ducks and they've had a pretty good response to it. And I think in the US we've vaccinated California condors because they're endangered, but no other bird species.
And I think keep in mind when you think about vaccines, we know vaccines aren't perfect. And when you think about human influenza vaccines, we know that they don't always prevent infection. We know that they're really great at preventing severe illness, right? They prevent hospitalization and death. And that's where we see great effectiveness numbers. But you can sometimes go on to develop an influenza infection, even if you've been vaccinated. It's milder than it likely would have been if you were unvaccinated. But the same is true. And again, I'm not an animal health scientist, but the same is true in animals as well, where there is the potential if you vaccinate cattle or poultry, that they may still go on to develop illness and spread that infection among them, but perhaps won't have severe illness. So I know that that's one of the hesitations and considerations in vaccination, is that the virus could still potentially spread in those environments. It likely just would not cause mortality.
I'm going to combine, thank you, a couple questions here. Everyone's got great questions coming in. I'm going to try to combine a couple, which speaks a little bit to preparedness. Both what could we be doing better to be prepared in case, we do have an evolution in the virus, right? That could greatly infect more humans and spread more rapidly. So what are we doing? What could we be doing better to be better prepared in this realm? And I'm going to layer in the fact, the acknowledgement that there is federal funding that's being cut, and how is that potentially impacting any of our public health or other programs doing some of this work?
I'll just start with a few things. I think one thing that we have to have is, and I keep using this term, situational awareness. We have to know who's getting infected and where. And I think testing is very constrained right now in humans. It's not something that's being done point of care. We don't have tests that are available, at the site of farms to look at these sentinel workers who might be exposed. And there may be a lag in how quickly we notice that somebody is infected with bird flu, particularly when other respiratory viruses are circulating, including seasonal flu. And people go to a clinic and they might get tested and they get an antigen test, which just tells them flu positive or flu A positive, and we don't really type them. So I think there might be, we need to have a situation where people are actively looking for this. There's a lot more surveillance going on than at the farms, including of the workers. That's one part of it, so that we're ready to go. Then I think it's developing new human vaccines, and those are already being done. That there are companies like Moderna, as well as others like CSL, that have, or Seqirus, that have bird flu vaccines that are being bought for the stockpile, so that we can use those strategically in humans if we were to need that. We have antivirals stockpiled as well. So I think that it's going to be a whole host of things that need to be done, and I think it's a slow start. Again, we're still in a reactive mode rather than proactive, although there have been some steps with vaccine stockpiling.
I can add that at a state health department level, we have been through this really effective, though tragic, preparedness exercise in the last few years, right? The COVID-19 pandemic taught us a lot in preparing for a pandemic. And so I think there are many lessons learned from that we are taking and revising our pandemic influenza plans in the state. And a lot of that work for us is ensuring that we have the ability to scale to respond. So scaling testing, scaling vaccination. And for us at the state level, it would be getting vaccines to people, scaling our healthcare system to be able to respond. So those would be some of the ongoing planning activities that we're engaged in. And honestly, are always engaged in, but of course are paying close attention to avian influenza.
I'll move on. I just in case Jack went to something in there. We've had a couple questions around the frontline workers and ways that they are being supported because they are being more directly at risk and are impacted, whether that is help with medical costs or other things. Are there measures in place to support those? At least in Colorado, I'd be curious if there's something nationally too that you all are aware of.
Yes, so I can talk to some of the activities that we have ongoing with our agricultural partners. So maybe first to speak to the response work that we engaged in over the summer. So in showing up at those farms, we knew that we would not have immediate trust with workers. The workforce is a very vulnerable workforce, does not speak English, oftentimes does not even speak Spanish. And so what we did is we brought translators, we brought cultural navigators to help us with that response and develop trust with the workforce. We have also found that engaging with community partners who have existing ongoing relationships with this workforce is really important in trying to develop trust and encourage folks to to seek routine vaccines or to seek testing when they develop symptoms. So those steps I think have been really important. But I do think that there is more work that we can do at the state level and nationally to ensure that we are doing the best we can for this vulnerable workforce.
Yeah, working with the big companies, I can tell you that the greatest challenge of putting these procedures we're talking about is culture. And this is a very transitory workforce. To Rachel's point, it's gone from, different cultures, and it's a real challenge for these big companies to be able to manage that. I would say this is maybe the biggest concern I'm hearing from these big companies on managing the production facilities is the nature of the workforce.
Amesh, anything nationally regarding the workforce that you're aware of you want to add to that point?
I know that the Department of Agriculture and CDC have offered personal protective equipment to some farms, and there's a program. I'm not sure what the uptake is. I think not as many farms as there are have actually taken them up on this. But there definitely is a recognition of this, but I don't know that there's really been a robust program that's been upticked by those farms. Again, a lot of this has to do with the farms being willing to do this, and there has been that hesitancy and reticence of the farms to engage in this because of the economic implications and the stigma of a farm being impacted by COVID-19. And then there's also just a logistical thing of, people wearing PPE when it's over 100 degrees inside in a poultry barn. That's very, very very challenging. So I think that's also been constrained, but I think everyone recognizes, at least in the public health and infectious disease world, that these workers are going to be the first people infected. They're going to be the ones that are they're the sentinels for the rest of the human population, and they're at extreme risk compared to the general population.
Thank you. Just someone had made a comment, wanted to clarify the PPE that folks do wear if they do, you know what I mean? Is it enough to keep them protected and safe if they're wearing masks and spectacles and gloves?
Okay, so it's a little complicated to answer. So I will say that I think it's important to recognize that a lot of PPE is really designed for use in healthcare settings, and a poultry barn in particular, or even a dairy farm, is a very different environment. And one of the things that workers and farm operators need to take into consideration is overall worker safety, right? So if you put on goggles, which are probably the most protective for you to protect your eyes from splashes of milk, like that's the ideal PPE we want you to be wearing. You also might have peripheral vision challenges. And we've been told by farmers that they are worried about being kicked by cows if they have goggles on because they can't see the cows as well. So I think there's all of these challenges in these environments that you have to take into consideration. In poultry barns, especially when it's 100 degrees, there are these really high powered fans. And so you think about the amount of dust and debris that is in the air and getting behind glasses or getting behind goggles. And most of the folks that we've seen that have had infections have had conjunctivitis or pink eye type symptoms. Their eyes have gotten infected first. So I think there's a number of complexities, a number of limitations in PPE, and that doesn't even get to the challenges of for PPE to work, you have to be wearing all of the PPE. And as you've heard, it's really uncomfortable at 100 degrees to wear all of this PPE that's recommended.
Thanks. Jack, anything to add to that? Or if not, I would love to ask you a little bit about the egg versus poultry difference. If you could elaborate on that. And someone specifically was also curious about, laying hens versus broilers and why we haven't seen a shortage yet in any chicken consumption.
Yeah, just one more thing to add to what Rachel said is there are geographical differences on the belief in using PPE, and even to the extent that this virus is an issue, right? And so that permeates into how these tools are being applied, which in our, from my experience in manufacturing is always the biggest challenge is the utilization of the PPE, the proper use. Moving on to the poultry, the broilers versus the hens, it really is a supply chain cycle issue. So a hen will be in a production facility for 5 to 12 months. So there are all these hens in this facility. So you can imagine managing sanitation, managing testing, everything like that is much more challenging versus a broiler cycle is very quick. Hopefully nobody quotes me. I think it's like 5 weeks. So basically, you basically go through the whole cycle of growing the broiler. You take them all out of the building, and then you can do a clean sanitation and manage everything much better. And so that's the main reason why you're seeing this problem becoming more relevant in egg facilities versus broilers.
Great, thank you. I have a great question here. Maybe Amesh, you can start, and I'd love others to chime on too. And I'm just going to read it because it's nicely framed. Effectively communicating the risk of zoonotic diseases like bird flu is critical for public awareness and response. In a time of misinformation and pandemic fatigue, what strategies can we use to ensure the public understands these risks without inciting panic, while also encouraging proactive behaviors that support public health and food security?
So I think that's a hard question, and it's harder to do than what my answer will be. But I think it has to do with generally communicating to the public about what's known, what isn't known, how certain people are about about specific conclusions regarding human risk, or what the virus may be doing, or how a vaccine might work, or what the plans are, and frequently updating people. I think that what happened during the pandemic is sometimes people don't understand that science is going to adapt to new facts that are found out about a pathogen or new things that occur. And I think you have to be really clear about that. That right now, for example, H5N1 doesn't pose a major risk to the general public. There are factors that we're looking at where that would change that. And I think it's really important that people know that and have it articulated ahead of time. And it's also important to say where the risks are and where the risks aren't. So if you say you're drinking pasteurized milk, that's not a risk. If you're drinking unpasteurized milk, that could be a risk. If you're giving your cat raw pet food, that is a risk. If you're not giving them raw pet food, it's less of a risk. So I think you have to kind of give them all the information that you have, and then express how certain you are about that, and give them that caveat that things might change. These are the things we're looking at that could influence how our guidance might change. And you have to do that very frequently and very openly, and not kind of pontificate from on high. It has to be really taking the way we deal with other infectious diseases like HIV or hepatitis C. I think that's the model we need to use when we're talking about these infectious disease emergencies, where we're very clear to people on protective measures that they can take, what the ironclad best protective measures are, what are a little bit less. It's a concept called harm reduction. I think you have to kind of put that into it. And I think a lot of that was missing during COVID. And I think that's why so many people tuned out. But it's harder to do than actually, it's easier to articulate these principles when it's harder to do them on the fly.
And I think we're in a time of fatigue as well, and talking about infectious diseases and public health issues. And we need to keep that in mind. I think we obviously need to talk about the facts and the science and get the facts and the science out there. But I think we also need to be aware that the people have different values and different risk perceptions and are going to receive that information differently. And people trust different voices. Like I might be CDPHE spokesperson, but there's a certain portion of the population that probably isn't going to listen to me, right? We need other spokespeople to talk about public health problems. And so I think it's important that we recognize that, and recognize that we need to have a broad group of people that are talking about some of these issues, and we need to convey messages in a different way, and recognize that not everyone's going to receive them the same way.
Jack, anything on how should we be talking about this and communicating better?
Well, I mean, I'm really happy that we're having this conversation, because I think we need to have cross-disciplinary conversations. I mean, I really enjoy talking to the scientists, because science impacts supply chain and vice versa. And I think we have to get out of our groups and have collaboration. So I appreciate this.
Great. I appreciate you being here today, Amesh, Rachel. I appreciate all three of you and your perspectives. I think this is just the start of hopefully learning about this and continuing to help inform a broader public I want to thank everyone who did join us today. We did not get to all your questions. I'm going to try to curate some of them and hopefully we can get some responses for you in our follow-up. But I just want to extend my gratitude to everyone for your time today and sharing your expertise. A huge thank you. I learned a ton myself. And a huge thank you to our audience as well. We'll follow up with the recording for those of you who want to pass it along as well to others that you think would learn from this. So thank you all very much and enjoy your weekend ahead.
Thank you.